Hello my dear students, welcome to the class of 11th English medium. The subject is statistics, chapter 3. This is the first tutorial for the chapter 3, that is measures of central tendency, brought to you by Vitan sir. This is a very easy chapter, the base of which you have already studied in the 10th standard. Now, statistics may rightly be called as a science of averages, and this was told by Sir A. L. Bowley. Bowley is a person, is a statistician of which you will hear a lot in the future statistics subject. So, statistics can be called a science of averages. Let us understand this statement using some examples. Daily money spent on milk in a month. Now, this is something that during a month I made a total spending on milk, and I want to know that how much money did I spend on milk per day. So this is an example of an average. Then average monthly production in a factory during a year. So during a year, I produced some commodity in a factory. Some months I produced more. In some months, my factory was closed. I want to know what was my monthly production in a factory. So that would be an average. So total production divided by 12, it will become an average. So average is statistics basically. Per head contribution while dividing expenses of a trip. Now this is a very simple, logical and practical example here, that for example you and your friends are going on a trip and you spent a total amount of money. Now while at coming back from the trip, you want to see what is the contribution per head for the trip of the total expenses. So that is also an example of an average. Apart from using average in a simple topics, we can also use averages for comparing one or more, two or more things. For example, comparing two states based on their average annual tax revenue for past 10 years. For the past decade, what was their average annual tax revenue, and then comparing those two average annual tax revenue depending on the two states to decide which states gives us a higher tax revenue per annum. So this could be an example of comparison of two averages. Then comparing two employees based on the average monthly performance of the past year. Maybe I want to give a promotion to an employee, so I will just find the average monthly performance of the past year and decide based on that whom should receive the promotion. So again, average becomes useful in this kind of a case. And lastly, deciding a better mobile based on the average standby time. Okay, the mobile phones with good batteries give us longer standby times, and I want to buy a mobile based on a longer standby time. So for that I will compare them, compare various models of mobile phones based on their average standby time. So again, I am using an average in this perspective. All of these situations, all the examples which I just gave, hint at a certain fixed number which represents the whole data. That means there is a fixed number which I am using as a representative of the whole data. So that particular fixed number or a trend which I am finding representing the whole data is called central tendency. So here I am using a particular number or particular characteristic to represent my all of the data. For example, the number of the money spent on milk per month depicts the whole yearly data of the milk. So per head contribution of a trip depicts the total contribution, the total expenses, the total number of people on the trip. So that particular number represents the whole data, and we call them the central tendency. Also, its value is called measure of central tendency. So the characteristics, so the central value is the central tendency, and its value which we calculate is called the measure of central tendency. What this measure of central tendency does is, number one, it presents the data in short and concise form. That means the whole big bulky data has been expressed in a single number. So that's short and concise. Second, it shows the special characteristics of the data. That means the special characteristics of the data are presented using the measure of central tendency, and then it also helps in comparison between two or more sets of data. That means we can compare using the measure of central tendency two or more companies, people, factories, states, countries, cities, homes, families, anything we want to compare, we can compare using the measure of central tendency. Okay, in 10th standard, I told you guys that you did study some measures of the central tendency. The measures which you studied were mean, median, and mode. Now, you just studied very simple things. For example, how to calculate mean and median and mode and the frequency distributions and all that. You did study, but actually there are too many subtypes of the averages. Even in this tutorial or in this chapter, not all of them are included. So I have just prepared a graph showing what you are going to study in this particular chapter. The averages here I have divided them into two main parts. First part are the observational averages. These are the averages which actually uses the whole of the observations in the data. That means all the observations of the data are used for calculating this kind of averages. And the second kind are the positional averages. Here the actual value of observation doesn't matter, rather what is the position of that particular observations in the group of data matters. So I call them positional averages. Now the first of the observational averages is the arithmetic mean, or in a simple terms just mean. What you studied in 10th as a mean is actually the arithmetic mean. That's its original name. The second kind of mean is geometric mean. Yes, we are going to study geometric mean and the weighted mean in this chapter only. So apart from arithmetic mean, which you usually know as mean, we are going to study geometric mean and weighted mean. Positional averages are of two types, median and mode. Yes, median and mode both are the part of the positional averages, because median basically calculates the middle value of any observation, set of observations, and mode calculates the number of observations which has been repeated for the maximum number of times. So again, the position of the observations matter. So technically mode is also part of positional averages, but median also has some siblings, we can call them. Those are quartiles, deciles, and percentiles. So these are the averages or measures which we are going to study in this particular chapter. The arithmetic mean, the geometric mean, the weighted mean, the median, the quartiles, decile, percentiles, and the mode. Okay, and that would be for the discrete data, the continuous data. Even mode has some graphical methods, and then again we have to use some shortcut methods whenever it is possible. So there will be a lot of formulas, so pay attention to each and every formula which I will be giving in my further tutorials. The last topic which I am going to discuss in this particular tutorial are the characteristics of good measure of central tendency. Yes, measure of central tendency are many, but not all of them are good, not all of them are efficient. What we need is a good measure of central tendency, and how to decide that a measure of central tendency is good. There are certain points I have listed out here. Number one, the measure should be well defined and rigid. A measure cannot be a flexible measure. It can't change with the situation. It should be rigid. It should be well defined. It should be understandable. That comes to the second point, that's easy to understand and calculate. The measure should not be too complex or too difficult to understand or grasp at the calculations. If it is so the case, if it is very difficult, then of course we can't use it practically. For the sake of practical use, we need it to be easy to understand and easy to calculate. The third point here is it should be based on all the observations of the data. So naturally, only observational averages should be the good averages, because median and mode does not calculate based on all the observations of the data. That's why arithmetic mean was considered the best average of all. Second is next is suitable for further calculations. Yes, the averages should be suitable for further calculations. It should be easy to calculate further. Next, we should have a stable and reliable average. That means no matter if the population is same and we take different samples of the same size, our answer should be same. That means by just changing the sample, our average should not differ from the previous answer. So it should be stable and it should be reliable. Last point is it should not be affected by some very small or very big observations. That means out of the 10 observations, if 2 observations are very small, our average should not be affected. And likewise, if 2 observations are very big, similarly our average of it should not be affected. So if that is the case, then it becomes a good measure of central tendency. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.